Hello everyone, let's go ahead and look at an application problem. We're going to have to use the law of cosines to help us figure out what's going on. So in this example, we are told that we are on a boat that leaves its pier and heads east for 25 miles. To avoid rough seas, the captain turns the boat and follows a bearing of south 40 degrees west for 13.5 miles. And so with this information, we want to figure out how far are you from the pier. So let's go ahead and get our own bearings set up. So north is up, east is to the right, west is to the left, and south is downward when we're drawing our picture. And so let's go ahead and let this be our starting point. Maybe this is when the boat is at the pier. So the first thing the boat does is it leaves the pier and heads perfectly east for 25 miles. So we're heading off to the right for 25 miles. And now at this time, the captain decides to avoid some rough seas and turns the boat and follows a bearing of south 40 degrees west. So we have to know how to interpret that bearing that is given of south 40 degrees west. And here's how we can do it. So south is just going straight down. So here we have our pen pointing directly south. And if we want to change that to a bearing of south 40 degrees west, we need to rotate our pen 40 degrees west. That is, we need to rotate our pen 40 degrees in the westward direction, or to the left, or clockwise. So here is a rotation of about 40 degrees west of south, and that lands us on our bearing of south 40 degrees west. So we travel in this direction of south 40 degrees west for 13.5 miles. But we haven't really even finished drawing our triangle, because what is this question actually asking us for? It's asking how far are we from the pier at this point after we travel on this bearing for 13.5 miles. So really what we're trying to figure out is what is the distance from our starting point to our ending point here, and connecting those two dots is going to finish creating our triangle, and we are essentially looking for this missing side length in our non-right triangle. So we know two of the side lengths in our non-right triangle, and we also have some information about an angle. So let's go ahead and use that information to help us find an angle within our non-right triangle. So recognize that this first bearing was east, which is a nice horizontal line. That second yellow line was part of figuring out our second bearing, and that is perfectly south, or a perfectly vertical line. So our east and south lines are going to meet to create a nice 90-degree angle. So that means the angle within our triangle is going to have to be complementary to 40 degrees, add up to give us a total of 90. So that means this angle here is going to have to be 50 degrees. That finishes off our nice little right angle. And now we know two side lengths in our triangle, as well as the angle between those two side lengths. And that's enough information to find that third side length. And we're going to use the law of cosines to help us do just that. So we have like three different versions of writing down the law of cosines depending how the side lengths and angles in our triangle are labeled. So let's go ahead and add some labels to these side lengths so we can figure out which version of the law of cosines to use and start using it. So let's go ahead and call our missing side length A. So then the angle opposite of that side length A is going to be our angle A up here. And now for these other two side lengths, it really doesn't matter which one we call B or C. Let's go ahead and say B is 25 miles, and the side length of 13.5 miles will represent C, or our side length C in our triangle. So now we're going to be using the law of cosines to help us find a missing side length in our non-right triangle. And we always want to use that version of the law of cosines where that missing side length is that number squared by itself on usually the left-hand side of the equation. So the version of the law of cosines that we're going to use to help us find side length A here in this problem and find the distance we are from the pier is going to look like A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. Or we can always double check this. Which information do we know in our triangle and which information don't we know and are we trying to figure out? Well, we know side lengths B and C. So that gives us a lot of the information we need for the right-hand side. We also know the angle between side lengths B and C is 50 degrees. That's our angle A. So we have all the information to fill out the right-hand side, and that'll help us find that unknown or remaining to be found left-hand side of A squared. All right, let's plug in everything that we know about our situation. So b squared is going to be 25 squared. C squared is going to be 13.5 squared. We have to subtract away from that 2 times the product of those two side lengths. So 2 times 25 times 13.5. And then we have to multiply that by cosine of our angle, which is 50 degrees. And so we can go ahead and evaluate the right-hand side of that equation using a calculator. And what the calculator should give us is that a squared is approximately equal to 373.37. Remember, this is a squared, not a itself. And so to find a, we just have to take the square root of a squared, or the square root of 373.37. And that gives us a value of approximately 19.32. And our units here are miles. So using the given information, we were able to determine that we are approximately 19.32 miles away from the pier.